I genuinely could not be more excited for this project. I've been sitting on this one for a while, have to admit it, but it is December now, and no better time to take a look at this machine. One of my holy grail machines. This is a Commodore big box, but no, this is not an Amiga. This is their XT clone, the PC10-III. Now, this machine was very kindly sent my way by Simon from Ginger Hippie Gaming. He has sent us a couple of other bits in the past, notably the PC Engine and the VIC-20 that we looked at a couple of months ago. And as you can probably tell by the state of this, well, this XT clone, this was pulled out of the same warehouse that those other machines came from. And in fact, you may very well have seen one of these or something very similar last year on RMC's channel, because from that same place, he got a PC10-III. Not really sure yet what the difference is between the 20 or the 10, but I'm sure we can figure it out as we go. This machine is just a basic XT clone, but there is something very special about the chicken lip logo, that Commodore badge on the front of it. As I'm sure you know, I love my Commodores, so that just makes this extra special for me. Now, given the state of the keyboard on the outside of the case, I have to be honest, I am a little bit nervous as to what condition we might find inside, because this machine did have one of those dreaded Varta batteries on the board. In fact, it may still have that in there. I genuinely have not taken a look yet, but I don't think I can wait any longer. So let's swing around to the bench behind me. We'll take the screws out and get stuck in. So how do we get into this? Well, it looks like there used to be a couple of screws on the side here, along with the keyboard port and what I would assume is a reset switch. But those are out, and that's because the previous handler of this machine, and I do need to say a massive thank you to him as well, because Matt from the YouTube channel Tech Made Easy, he very kindly handled the shipping of this to me. But he was in here in the past, and those screws, don't worry, they are included. They're in this little bag. I think it's the same on the other side. Yeah, there was 2 screws in there, but those are out as well. My goodness, this thing is heavy. And that just leaves these 2 screws on the back. Now, as we can also see here, doesn't appear to be anything in the expansion ports. And in terms of onboard ports, well, we've got parallel, serial, RGB, composite video, and a mouse port, which still has the original Commodore sticker over it. We'll take a closer look at that in a second, but hopefully that is the lid released. And so, moment of truth. Well, the initial thought is this doesn't actually look too bad. Of course, he says that, and then check out that IC there. Presumably one of the RAM ICs that looks like a bank of memory, and that is kind of green, as is the one beside it. And a little bit of corrosion on them as well. So I think all we can do is continue to strip this down. Need to remove the hard drive, the 5¼ inch floppy drive, the PSU, and then presumably this whole cradle here to get the motherboard out. This machine must have an onboard hard drive controller, and indeed floppy drive controller. I was half expecting to see an expansion card, and it looks like it is an XT class hard drive. But yeah, we do need to get into this board to see just how bad the corrosion is, so time to continue the strip down. And there's something you don't see very often inside a computer, which in some ways just goes to show the age of this machine. We have flat-headed screws. And those definitely haven't been out before. That was kind of tight. It's a Western Digital, model number WD93048. Looks like the 3 has been handwritten on there. It does have a couple of defects on it as well. I'm not sure, but I would hazard a guess that this is a 20 megabyte hard drive. Just want to pause things for a second while I'm doing a bit of editing here. I didn't notice the amount of glare that was on the top of the drive, so here's a better picture of it. But I've also looked up the part number of the drive, and we can see there that it is indeed a 40 megabyte drive. So maybe this machine has had an upgrade at some point in the past, because I don't think they shipped with 40 megabyte drives. I'm not even sure the PC10 shipped with any hard drive. So moving that ribbon cable out of the way has indeed exposed those pin headers, presumably for the floppy drive and for the hard drive. So it obviously must have those onboard controllers. Let's try and get that power supply out next. Or maybe not. I've removed all the screws from the back of it, but it must be screwed onto this plate from below. Can we get the floppy drive out? I don't know if this drive is sitting on a rail in here. I'm not sure it is actually, so I'll just loosen those and then we'll take them out the rest of the way by hand while supporting the drive. Yeah, that's it out. And no, there are no rails in there, so just as well I did keep a grip of that. That has exposed a little bit more of the motherboard. And yeah, there are some signs of rather light corrosion in around here, but it isn't looking too bad. Just let me spin the case around one more time, because I think the last thing holding it together is this screw here. The whole thing sort of feels as if it wants to fall apart at this stage. Oh, there's a screw equally on the other side as well. Of course there is. And then if I remove this other screw at the front here, that will actually allow the whole front cover to come off. We do need to strip this right down to its bare bones though, because it all needs a really good clean. So there's that away. Then I think the rest of this will just lift up. Yep. There we are. The Varta is still in there, but there it is. Our PC10-III. Let me get the motherboard out of the case and then we'll get a closer look at this area. Looks like there might actually only be this one screw here left holding it. Feels like it's been held in the middle somewhere. Where's the other screw that I can't see? Ah, there it is beside the battery. And my goodness, it looks kind of mangled. Nope. Come on. Nope. That is not for coming out. Remove those two from the serial and the parallel port. Only was the two in it. We are missing the other two, plus missing the ones from the RGB port and the mouse port. They'll need to come out to get the motherboard free. But I do need to deal with that. As tempting as it is to get the Dremel out, I wonder can I just snip it off of these? Or in fact, what I'm going to try and do is create a slot in this so that we can put the plain screwdriver into it. Now if you take a look where the points of the star were, there's one of them sort of in that position. It's not really cutting. No, it's not really cutting it. I thought, considering the corrosion on it, I might have been able just to snip through what was left of the screw, but no, it's not happening. We need a little bit of motorized help. Now we do need to go really easy at this. I'm coming at it from this angle because this thing turns as such. So hopefully any shavings of any metal that it cuts will go this way rather than all over the motherboard. Please don't slip. Let's see if the big plain head here will get it out now. No. It is welded in there. I don't even really have enough space around here to say try and put a pair of vice grips on it. I wonder if I maybe could. If we cut that battery out, we will obviously desolder the remnants of this later. For now, I just want to get it out of the way. Right, it seems the borrowers have taken my vice grips, so I wonder, can I get it with these side cutters? These might get a decent enough grip of it. And be very careful to keep this clear of the board. Yeah, starting to go. Bloody batteries. They do make some mess when they leak. Nope, this just rung off. I half expected that, to be honest. But that should now be the board loose. Yep, here it comes. Aye, look at the state of that. So yeah, some cosmetics to do. But no point in doing any of those unless we can sort this out. So it obviously needs a good clean. There is lots of dust on it, and I will give it all a good going over with a toothbrush in a minute. But taking a look around the damaged areas, well, obvious one first of all is around the battery. And I think we have been extremely lucky here. Yeah, there is a bit of corrosion in this area here. Over this side of the battery, it's not too bad. It's actually fairly light. It's just that sort of white corrosion just on the surface. And there's a little bit more extensive here though. So I will have to look up the part numbers of some of these components, because no doubt some of these will need to be replaced. Although it just seems to be a couple of 7.4 series logic chips, and presumably this is the RAM. LH21256, so 1-bit 256K each, and that makes sense, doesn't it? Because 1, 2, 3, 4, 5, 6, 7, 8. So 256, 512, and then just here, those 4 chips, they are 4164s. So 4-bit 64K each, that's 128 total there. 512, 128, that is our 640K of memory. The PC10 Mark III, or the third iteration of these machines from Commodore, it had the full 640K on it. The original PC10, it only had 512. And there are a couple of other features that this one has over the originals. We'll get to that later. I'm not sure what that package is. A little bit of corrosion on the legs of it, but hopefully we can save it, because that looks like a ceramic top. And I don't think I've ever seen a chip with a white ceramic top on it. That is pretty cool. And it must be a resistor pack. It says on the silk screen there, RP303, and yeah, R33. So 33 ohm resistors, I would assume. But this isn't the only damage on the board, because if we look over on the other side, well, can anybody spot the cooked component? Whatever this is, this has let go in spectacular fashion. Looks as if it must have been a resistor. Just beside it there, I can see on the silk screen an R, although the rest of the numbering beside it is, it has worn off. So we will need to maybe try and find a high-res picture of this board to try and figure out what that was. And there is a bit of residual damage on the motherboard beside it, but hopefully it cleans up okay. If by any chance it's to manage to damage that chip, that's just another bit of 7.4 logic. 7.4 LS244, I have plenty of those, so that can easily be replaced. But yeah, first job is just going to be a bit of a general clean. Just with the toothbrush, so I'll get this up on its end. And we'll try and get all the dust brushed off it. Well, it only got the quickest of cleans with the toothbrush, but I think this has came up really well. And yeah, the corrosion isn't too bad, but we are going to go ahead and pull the few ICs here with green legs. I just want to get this as good as I can get it. But before we start into that, how about a quick tour of the board? And in terms of that, the first thing that jumped out to me is actually the power connector, because I'm fairly sure that is the same power connector that was on the Amiga 4000. Even though this machine comes quite a bit before that Amiga, the Commodore just like this connector and reuse it. Well, it didn't use that in the 2000 or the 3000. Maybe by the time it came to make the 4000, they had a load of these left over from these machines, so decided to use them in the Amiga. I'm not too sure, but certainly odd seeing that connector on there. And the other odd thing, I suppose, is seeing the MOS branded chip in the middle of a PC motherboard. I just associate that so much with Amigas. And speaking of said chip, the MOS 5720, well, there's not a lot of information online about it, but it does seem to be handling the mouse port, and it seems that this machine actually might use an Amiga mouse, and certainly does use a Commodore mouse. We will have a look at that closer later. Just down beside that then, we have an FDC 9268 FDC floppy disk controller. And looking up a datasheet for that, it supports single, double or quad density disk drives. Never heard of a quad density disk drive, but certainly our 5¼ inch drive. Well, that's a Shinnon FZ 502. This is a double density 360K drive, which might actually prove a little difficult for me getting software onto this machine, but we'll cross that bridge when we come to it. We need to get it working first. The whole thing is based around the Faraday chipset, FE2010-A. That is essentially an XT chipset in one component, in one IC. So very much cost reducing the XT class computer from what IBM created originally. But one trick that this thing has up its sleeve, and one nice advantage that it gives this machine, is that supports running the system at the standard 4.7 MHz or the turbo 7.15 MHz, or when used with a 28.6363 MHz crystal, it can run the CPU at 9.54 MHz, so clock doubled from the original 4.7. And indeed that ties in with the processor, the Intel 8088, although this is a Siemens part. It is an SAB 8088-1-P and is a 10 MHz variant of that chip. This blank socket beside it, that is for the 8087 coprocessor. And then moving down this way, we have a Paradise chip, PPC1 3832C. Can't really find any information about that online, so I'm not sure what that one is doing. Possibly something to do with the video side of things, but it doesn't really make sense why it's over here. This is all the video stuff down here, because that one in the middle there, that Western Digital chip, WD8250, well, that is handling the serial port. Speaking of the video then, well again, that is a Paradise chip. The PVC4, the CGA video card essentially on board here. I would assume that is the BIOS ROM for the video, and it has 64K of memory in the form of those two 4164s. Just the three 8-bit ISA slots. I suppose you don't really need much more than that because so much is integrated into this board. You know, we've integrated I/O, video, hard drive and floppy drive. And then just the system BIOS itself, and I assume that's what that one is. Where's the hard drive controller though? That's one thing I can't figure out. Is it maybe built into the MOS chip? But yeah, we need to crack on and try and do some repairs on this. Speaking of which, a couple of other things that I have noticed is our ports. These are looking a little bit sorry for themselves, in particular the parallel and serial ports. Quite a bit of rust going on there, and on the mouse port. We should be able to tidy it up just with a little wire brush pen, although with the surface of these now tarnished, it only will be a matter of time before that rust comes back. We could always swap them out, as was typical for Commodore. They are Foxconn branded ports. And I suppose I do have a scrap Amiga 500 board with some pretty clean ports on it, and these have the same branding as well. But I think that is enough waffling. Let's warm up the desolder station, get some of this out, get that resistor out, and start to think about making this good. There we are. Yeah. Well and truly cooked. We have no chance of figuring out what that was from the bands on it. So I will need to try and find a schematic. 446, 445. I wonder, is it a 470 ohm? Now this IC beside it has taken a little bit of damage just when that resistor got cooked, but any of that sort of corrosion there, or whatever you want to call it, it is scraping off actually really easily. So it is just surface stuff. I don't really know if it warrants removing that or not. There is a little bit of it there underneath the chip, but to be honest with you, I think it'll be alright. We'll give it a clean with a bit of white vinegar and IPA later. But yeah, that's not looking too bad. And we can now just about make out the number of the resistor that we removed. Although the silk screen text on this is actually quite hard to read, it's a bit blurry for some reason. It's either R105 or 165, might even be 185, maybe 163, it's definitely R1 something anyway. But if we can find the schematics, I'm sure we can figure it out. Now in terms of things I want to remove over here, we'll pull these two ICs, I think these two, and the RAM chips down to there. So we'll pull that. Now for one of these first components that I'm going to remove, the solder points on the left hand side of it here, they are quite corroded on the bottom side. So the best thing I find to do is to get a bit of flux on it. And then with the iron, we'll try and melt some clean solder into it. It probably won't take very well just because of the corrosion. And sometimes with the flux there, it'll help it just work its way into it and sort of clean things as it goes. You can see that first pin there has sort of came up, as has the second one now. I know the board is looking like it's going black there, but that is just the corrosion. Just as I'm heating everything, there's the new solder starting to take to those pins now. Yeah, you could go at it with a fiberglass pen or something like that, but then I'm going to risk scratching up the board. And granted, I may scratch it up a little bit doing this as well, but it's just an alternative method of cleaning the thing. You know, drop a little bit of fresh solder just onto these solder points as well, just to help with the desoldering. I also find it easier with the soldering iron just to straighten any of those pins that were bent over from the factory. And I know it looks like a mess, but that will hopefully let us get that off. It is this one that we've been working on. Still looks like there's plenty of solder on the top side. Sometimes if we grab the chip and try to wiggle it back and forward, yeah, no, it's still well and truly on there. So I'm just going to try and do the same thing again. We're going to put a lot of flux on the top side here, as it is all quite heavily corroded. Then with the iron, we'll try and mix in some fresh solder just to try and clean things up a little bit. But now that we've done that, we'll go back in then with some braid and just try and mop this up now. And if we're lucky, that might be the chip ready to come out. Just thinking about it. Yeah, it's just this bottom corner here that's putting up the fight. What is that? I hope that's a leg. It does look like a leg, but hopefully that's all it is. A corroded leg that's snapped off that IC and not damage to the board. But all we can do is just keep working at it. So I'm going to put more solder on these points down this side. Let's try desoldering again. Hopefully that's it free now. Come on. No, it's still playing silly beggars in that bottom corner. Nope, there it is. We got it. A bit of a wiggle soon had it out. You can see the state of the corrosion that was underneath it. That is why I want to get these out. And yeah, it actually lost 2 legs in the process of doing that. So absolutely had to be replaced. That is some mess. Although I do think it'll clean up fine. So plenty more to do. I'll just get on with it. And then we'll come back and take a look at what we're dealing with. 3 ICs out so far, but we have had a disaster. First one that you see me remove on camera, it actually came out not too bad. There's maybe the tiniest little bit of damage on one of the pads on the top side here. Unfortunately, I cannot say the same for the next 2 that came out, because those 2 have taken quite a bit of damage. Now, these were probably harder to get out. The corrosion had well and truly worked its way into the solder on the top side, but I'm not trying to make excuses here. This is 100% my fault. This should not have happened, so please feel free to call me an idiot down in the comments below. I'm not really sure why the damage occurred. Possibly too much heat on my part. It was just exactly the same process here that I used for that one. But yeah, we have lost pads in multiple locations, so there's going to be quite a bit of repair work required. As you can see, I have exposed the copper on this as well, just using the Dremel with these rubber tips on it this time. And it does do a pretty good job. If I just go along this big trace here, well, you can see the way it takes that off, and it is quite gentle at it. But it's the sort of thing that I don't want to do on camera per se, because I want to be on top of it, looking at it directly rather than trying to look at it through the camera's view screen. But the other thing that I've thought of doing is to use this and try to go over the legs of the remaining ICs that I want to take out, just to try and get corrosion off them on the top side, or as best we can anyway. Then maybe try and flow some clean solder onto the points on the top side before desoldering. If I can get it mixed in before we use the desoldering gun, hopefully the desoldering gun itself will have enough to clear everything. That's the plan anyway. So let's see how we get on with this resistor pack. So you can hopefully see the corrosion there in the legs of that resistor pack. I'm going to go along it with this, as I said, to try and almost grind off the surface of that corrosion. And then let's try and mix in some clean solder to that. I'll go in with a little bit of flux. I'm just going to use this cheaper flux here because I'm burning through my chip far too quickly for my liking. It is expensive, that stuff. And let's see how this goes. And put a bit of solder on the iron. Yeah, that's working a lot better now. You can see the way that solder is taking to those legs straight away. Hopefully this will work better. So I'll do the same on the other side, and then we'll try desoldering. You can actually see there how some of the solder I was flowing on the top side has flowed through to the bottom side. Just going to add a little bit on the bottom side though. You can definitely see the crustiness in it, but let's try some desoldering. It all seemed to desolder pretty easily, although that pin is still stuck. As is that one, and that one, and that one, and that one. Yeah, it's not there yet. You can see a couple of those pins there are free, but the rest of them still have plenty of solder around them, and it's just down to the crustiness of it. It's horrible. And yeah, it is starting to go. Those pins are still well and truly stuck though. I've added a bit more solder right around it, cleaned it a bit more. Will it come this time? I think maybe that pin is problematic, but let's just see if she's going to come. Yeah. Yeah, there it goes. And that is kind of crusty looking. You know, when I first looked at this, I didn't think the corrosion was that bad. But the more you get into it, yeah, it's not great, is it? At least this time though, I think we've got that chip out without causing any damage at all. Or maybe that pad has maybe taken a little bit, has it? Or is it just corrosion on it? Yeah, it looks like it's been eaten away a little bit. I don't think I did that because the damage is on the back side of it. The actual hole that the chip was down through looks fine. It's just the outside of it. On the bottom side, yeah, things are still looking good. Much like those previous points as well. I mean, everything looks fine on the bottom side, but then, granted, a little bit of solder mask is missing here or there, but the actual pads and all are fine. So I'm only going to remove what I think is the absolute bare minimum. We can see corrosion the whole way down this, but it really doesn't look too bad, you know, down here. I'm maybe going to remove another 2 rows and we'll see how it goes. Well, I've removed more or less everything that I want to the left of where the battery was, but with more damage. On this IC here, I've lost a couple of pads, even managed to rip up part of a trace. I have no idea what I'm doing, but I have managed to destroy this board. It's seriously making me question what's going on. I'm not using techniques here any different from what I usually would, but the top surface of this board is just falling apart. I did even try a little bit of hot air on one chip that was being particularly difficult to get out. It was this one here. And just at that point there, just where that trace is coming down there, you can maybe see a little bit of the copper of that trace. I do need to still clean all this up with a Dremel. But just there, there's like a bit of the board that's a slightly different color. I'm not exaggerating when I say I had my hot air on that, just, you know, going along the side of the IC to try and free it up. But I had my hot air on that for 5 seconds and the board started to delaminate. I don't understand. Is it me? Am I doing something wrong here? Talk about a holy grail machine. I'm starting to think I picked up the wrong one. I've drank from the wrong cup here because everything I'm touching is just disintegrating. I can't tell you how annoyed I am with this right now. When the battery here has leaked, I think what's happened is that it's had a vapor leak rather than like a liquid has spilled out of it. Typically where the liquid sort of comes out of it, you'll see, you know, your heavy green corrosion on the board around that area where it sort of eats right down into the solder mask. We've seen it plenty of times on Amigas. But where you get that sort of vapor leak, I think what it's done here has attacked the top surface of this board more harshly, although maybe that's not the right word. It hasn't attacked it more harshly. It's just done something to the top of this board. You can certainly see along the top of the RAM ICs, certainly down here, and these couple, the writing has wore off those. So it's almost as if, you know, part of the top of this board has been sitting within like a cloud of corrosive chemicals in the air inside the case. And it's just wreaked havoc on this part of the board. It's just weakened everything. Now to the right of where the battery was, I was intending to try and remove some stuff here, just because some of these solder points are looking a bit crusty. But to be honest with you, at this stage, I'm worried about even trying to remove, say, those ICs, the clock chip and that 7.4. Because if I try to remove these, odds are on that I'm going to wreck it further. I'm going to cause more damage. Definitely don't want to do any more damage. So what I'm going to do with, say, the likes of these capacitors is I'm just going to cut them out. And then we can heat each of the legs independently and hopefully pull the remnants of the leg through. I'm going to recap the whole board anyway. These are going on for about 36, 37 years old, so they're well past their sell by date. These ceramic caps around here as well, I'm just going to cut them off as well. And in fact, nearly every one of those that I have desoldered so far, they have lost legs. Case in point there, that one, the leg just fell out of it. It actually cracked the case of it as it came out of the board. But yeah, the damage on this, I don't know what to say. It's genuinely making me even question what I'm doing here, because it should not have happened. I've been working my way around the damage, trying to make good, just by putting bits of wire down through holes where we need it, or even replacing hole traces with bits of wire. It is an awful mess, isn't it? But there's one more that I want to do, so we may as well try and show you one on camera. And that is this one here. Now, the trace coming down there is actually connected to what's left of that through hole there. But just given the state of that, I don't want to take any chances I'm going to put a wire down through anyway, and we'll bring it over, make it off onto the trace here, and then make it off on the underside as well. I've just been using this black wire that we always use, this solid core K-NAR type wire. What I'll do is just strip quite a bit of it like that. Yeah, that's way too much, but this is just how I do it. And we'll feed that down through the hole. Try to bend it roughly into the position that we need. Now there's way too much of it sticking through the hole on this top side here, but that's alright. Well, I'll just sort of orientate it like that over the top of the trace. We'll stick a little bit of flux down. Just tin up the iron with a little bit of solder, really doesn't need too much. Now I'll just hold that wire in place and just touch it with this. Alright, that's it. That should be that stuck down. So just at the edge then of where the wire is now connected to the trace, I just stick the knife down onto that. Just press down and that's a cut. That is how I repair those broken traces. So the next job is just going to be repopulating everything. I'm going to fit a lot of sockets where the ICs were removed. The new positives will just go straight onto the board. And I suppose while I'm at it, I may as well recap the other electrolytics. I don't think you need to see me doing any more soldering, so I'll come back when all that's done. Okay, recap complete. More or less everything has been repopulated other than the resistor that was in there. To locate everything in this region, I've been using the interactive bill of materials that was put together by the board folk when they remade this PCB for RMC. This one is exactly the same revision as our board, Rev 5.7a, although they have went on and created a further revision of the board that they have called the Rev 6, which does away with those couple of patch wires. It is really handy though, because if you want to know the value of any component, you can just find it on the layout. Say that capacitor there, C753, and that is 0.1 microfarad, that one there, the same as more or less all the decoupling caps on the board. So if we make our way over here to that resistor, I wasn't sure what number that was. It is actually R106. And using this, we can see that that is a 1 ohm resistor. So what is a 1 ohm resistor possibly doing in this region here? Well, if we take a look at the schematic, also created by the board folk, well, there it is, and we can see that it's sitting on the VCC supply to the keyboard port. So why was it fried? My best guess would be somebody has plugged in an incompatible keyboard, or maybe that keyboard that we have has a short internally, or maybe there's something wrong with that. Now, unfortunately, I don't have any 1 ohm resistors, but all that's doing in there really is acting as a fuse. So while I wait for one to arrive, we could chance it, and we could just fit a jumper in there. Although before we would risk plugging in a keyboard, we would really need to test that just to make sure that there's no issues on it. So I think that's what we'll do. What else could possibly go wrong on this project? And I'm just going to install that well off the board there, just because there are a couple of vias directly underneath it. I wouldn't want them shorting out to VCC. And I hope there's not much more soldering to do on this project, because that's all I've got left. I need to order a new spool. But I can get that at the same time as getting the resistor that we need. Okay, short of populating these ICs, I think we're ready to test it. Should we maybe just check force shorts? Just thinking about it. Should we check those on the power connector here? So we know this looks like the A4000's power connector, but is it the same pinout? If it were, these two should be both ground. And they're certainly connected. Yep, they're certainly connected to ground. So that should make that one 5 volt then. And we'll test that to one of the 7.4 series chips. And yeah, that is indeed 5 volt. I think this one then should be positive 12. And we can check that to the ISA slot. I think positive 12 is on pin 9 of the B side, of the back side of it. And yeah, there it is. That would make that one in the middle negative 12, which is on pin 7 up here. And then that last one must be powered good. You do need negative 5 over here. I don't think that would be negative 5 though, because up here on the board we have a 7905 regulator. That will be generating the negative 5 rail, probably off that negative 12 rail actually. Yep. And so that should be connected to pin 5 on here. And it is indeed. Pin 3 on the back side of the ISA slot, that is positive 5. Yeah. So anything shorted, well, between ground and negative 12, nothing there. Positive 12, that's looking okay as well. But ground to 5 volt is reading 65 ohms. That does seem really low, doesn't it? Although it's not a dead short, so it may well be fine. So you could potentially use an Amiga 4000 PSU to run that board, but I don't have one of those. And I know you can get adapters to go from that to an ATX power supply. The likes of Amiga kits sell them, but again, I don't have one of those. So all we can do is use this power supply. I've taken the screws out of it just to get a look at how it is inside. Kind of dusty would be the first impressions, but looking through all that dust, the rest of it does seem to be okay. I think what I should do here is just dismantle this further. We'll get the PCB out of it and give it a bit of a clean. All cleaned up not too bad in here. The fuse is still intact. So yeah, I do think this is okay. Looking around the bottom of it, there's no sign of any of the caps having leaked or anything like that. So I think we'll be good enough just to run with this. I will reassemble it though, obviously, before we try to power it up. I think we should just give this a quick test before we plug it into the motherboard. So we'll stick ground up in there, and we'll just measure the 5 volt to start with. Connected this whole SCSI hard drive here just for a bit of load. This drive's dead, but it does still spin up, or try to spin up anyway, and let's see what it does. Fan's turning, but we're not getting anything here. That's weird. Sometimes that meter does that. Let's turn it off and on and try it again. Yeah, that's more like it. 4.88. A little bit low perhaps, but probably alright. Let's just try the 12 volt. 11.3678. Yeah, fluctuating a little bit. That is probably because of this SCSI drive and the fact that it's a bit borked. And I suppose overall it isn't actually that much load for the PSU, so happy enough to call this good for now. Next thing to do is just hook it all up and test it. Before we do power it up, I thought it would be a good idea to remove all the socketed ICs, just reseat them. The two PLCC chips, well, I've got the 5720 out after much wrestling. You can see, unfortunately, the PLCC tool has took the corners off it. That did not want to come out of there, just because there is quite a bit of corrosion, especially on this side. In the end, what I had to do was use those holes. use those holes on the motherboard and push it out from the other side. The Faraday chip though, that does not want to move. Even pushing it from the other side, it has not moved a millimeter. So I'm soaking the thing with contact cleaner. Hopefully that will work its way down in there a bit and free things up. In the meantime though, I'll remove the 3 DIP ICs, the 2 ROM chips and the CPU. Quite a bit of dust underneath that one. Equally underneath the CPU, and presumably under this one as well, but at least they are coming out okay. And yeah, definitely worth removing them just to give that a clean. But what about that Faraday chip? Do we have any hope of getting it with this? Now I know you're just supposed to squeeze this and let this thing extract the chip itself, but that is not moving. Sometimes if you just rock it, there it goes. Yeah, we're out. You can actually see marks on the bottom of that from where I was pushing it to try and get it to move. And just like the socket beside it, that one is quite heavily corroded, especially on that bottom side. So plenty of contact cleaner in both of those. I'll just give it a go with cotton bud to start off with anyway. And yeah, you can see it is kind of dirty. Do the same again on the chips themselves, because yeah, those pins are quite tarnished. Then I'll just clean out the dip sockets, give them a blast of contact cleaner as well, and we'll try it. All cleaned and refitted, but we do now also have other components in sockets, so we may as well test these as well. Just give us some idea of the condition of the RAM. You know, if these 4 all test okay, well, I would say it's fairly certain that the rest of the RAM would be okay as well. And while those 3 logic ICs were replaced, that one wasn't. That one was just put back in there. So we can test that using the TL866. And we can test the 41256 RAMs using this thing. To test this chip in particular, we put it into the middle socket here and press go. But it does take a while to do that, 82 seconds to be precise. So while we're waiting, let's test this thing. So if we pull up XG Pro and go into the logic tester, it is 74158 and test. That's bad. I was not expecting that. But at least the RAM chip is passed. 4 purple lights, that means that one is good. What about the rest of them? Bad. Let's just try reseating it. Yeah, that's bad. Now, just because that chip was in that position, that's not necessarily the position it came out of. I just put those 4 back in any order. I'll try another one. That one's not even beginning to test. Oh no. Yeah, that one must be completely cooked. What about this one? And it is just the same. That is completely toast as well. Yeah, it's not even trying to test it. That is not good. Out of the 4 DRAMs, 3 of them are bad. That makes me think that more of these might be bad. But as you know, getting these out, it is a complete nightmare. The only way I think I could go about removing these without potentially causing any more damage to the board is to cut them out, to cut the legs of them and then just remove all the legs one by one. But obviously if we do that, we are rendering those chips useless, because the remnants of the legs that would be left on them would be far too short for ever reusing them, you know, for ever putting them into sockets. And the amount of effort it would take to solder new legs onto them all just to test them in this. Yeah, I think if I was to cut them out, it just renders them dead. Now, I do have plenty of spares. I'm just taking a quick look through my box. I mean, I've got all those ones spare, just lying loose. But I've also got a few Amiga RAM expansions, which use the same chips. And you know, there's any amount in this that could potentially repopulate all of that. But I'm thinking for now, what we should maybe do is just stick new chips into those positions. And I need to find a new 74LS158. We've got a problem. I've been through all my spare parts. I've looked over all my scrap boards and I cannot find any 158s. So well done, Commodore. It seems you have used a rather obscure part on this board, and it just so happens to be the part that has failed. Well, I say that. It's an obscure part from the point of view of what I currently have in stock. Now, I do have plenty of 157s, which is a very similar chip, the only difference being that the outputs of the 158 are inverted. So I suppose I could take a 157 and turn it into a 158 by running those outputs through 74LS04. The only problem there being that will introduce additional latency on those signals, so it might not even work trying that. Although I will have to order a replacement for this, and I suppose for all it takes, will we try and make a 74LS158. And so 20 minutes later we have this mess. One socket into which there is a 157, then sitting on top of that is an 04. The outputs from the 157 are being inverted by the 04 and then fed back down into the socket. So we stick that in here now, and if we pull up XG Pro again, into the logic test 74158. Yeah, that now works. Question is though, will it actually work in here? Because obviously we are adding a little bit of delay because of the two ICs. But I suppose there only is really one way to find out. So yeah, 3 out of the 4 RAM chips bad. That one logic IC bad. Does make me think that we might have other failed RAM ICs down here. Perhaps those ones on which the writing has wore off, because obviously they have been affected the most by the corrosion. But let's just test it at this first of all. Let's see if it's doing anything. Power supply hooked up, and I've also connected the original floppy drive and the original hard drive back there just for a bit of load. Give us a good opportunity to see if this hard drive spins up. Video, I'm just taking out of the composite output directly into the capture card. Let's see what happens. Well, no video signal unfortunately. Some good news though, the hard drive seems to have initialized, so hopefully that means that is working. But why are we not getting a video signal? Let's try a quick reset. And no, it's dead. Okay, I've been taking a look with the logic probe and I found a problem. Hopefully it is the problem that's stopping this from working. Certainly is something that would stop it from working, but let's first of all show you how we got to it. Well, first thing I checked was the obvious, reset and clock. Reset is on pin 2 of the ISA slots on the back side. Easiest place just to test it really. And if we power cycle quickly, you see it starts high, goes low. So that's fine. Clock on the CPU is on pin 19. And yeah, okay, we're not measuring it with this device, but it's pulsing away there. So odds are on, it's fine. Looking around the rest of the CPU as well, the likes of the address and the data bus, which are all down this side of the chip, well, everything there seems to be pulsing fine as well. Now, on the 8088, address lines 0 through 7 are shared with data lines 0 through 7. But if we take a look on the ISA slots, Well, on the component side, on the A side, pins 2 through 9, they are just solely the data bus. And you can see there that everything is held high. The address bus, it's all pulsing away, so presumably is all fine. But what's going on with the data side of things? So if we take a look at the schematic, the data bus can be traced from the CPU, first of all, to this 245. And we can see there on the CPU side of it that everything is pulsing away. But on the bus side of it, everything is just held high. Same way it is obviously on the ICs slot. So first thought was perhaps this chip is bad, and it may well be the case that there is a fault in there, but that is not the fault that I have discovered. And the reason that I think that there could potentially be an issue in there is if we take a look at pin 1, which is the direction pin, well, that is pulsing. And pin 19, which is the chip enable, that is pulsing. So with them both pulsing and the pins on the A side of this pulsing, you would expect to see the pins on the B side pulsing, but they're not. Now, that's not to say that there's not something else on the bus that is pulling those lines high. So when tracing that, it is the B data bus according to the schematics, and it sort of goes everywhere on this board. First port of call is this 245. This is handling communication between that B data bus and the RAM itself. But this chip does seem to be working fine, in so much as the direction pin is pulsing, the chip enable pin is pulsing, but everything is high on the input, everything is high on the output, or on the A side and the B side. So the assumption there would be that that chip is okay. It then finds its way over to another 245 on the other side of the board, and this is handling communication to the floppy controller. This time though, the direction pin, that is held high. The output enable pin on this one is just tied directly to ground. But that direction pin, that being high, that could potentially be a problem. The B data bus also makes its way to this 245. This one is dealing with communication to the hard drive. Again, the direction pin on this one is stuck high, but this time that is definitely wrong. The chip enable pin, that is floating. So that chip enable pin, that is getting a signal from U326, which is an LS08, which is this component, and it's getting that on pin 11, which is an output, from pins 12 and 13, which are inputs. So the 08 is a simple AND gate, and with pin 13 pulsing, pin 14 stuck high, well, you would be expecting the output on pin 11 there to be at least doing something, but it's doing nothing. So that would make me think that that chip is indeed bad. But the other thing that I discovered, because, well, I thought, let's just go right around this chip, pin 1 on it, that is acting really weird. You get a flash of low when you first touch onto it there, but after that it is just floating. Now, following that back and referring to the schematic, pin 1 of that, well, that should be connected to pin 6 of the 74LS10, which is this one of the ones that we replaced and did a lot of work around. But it seems that as part of that work, I have missed one broken trace. We have missing connectivity there. What's pin 6 doing? Well, ultimately, via this thing, it is controlling the RAS signal. So with no row address strobe, the RAM ain't going to be working right. The CPU will not be able to read and write to the RAM. It won't be able to run anything. I think that is what is stopping this from working. So 2 jobs. We're going to cut that out, pull all the pins, fit a socket, and just run a patch wire on the bottom side, because the break, the bit that is damaged, is unfortunately underneath that IC. The trace comes down here to a via just in there, just at that point. Not sure if you can see it on the camera or not, but the break seems to be just at that via, that is connection to the trace beside it. There'll be no way to repair that without removing this socket. I don't want to remove this socket because if I take that off, that will undo all the other repair work that I've done. So we'll just run a patch wire in this instance. Well, unfortunately that didn't fix it. Still just no signal coming out of it there. The old chip, when it came off, it actually split in two. Just as I cut the last couple of legs of it, it just fell apart. I'm not sure if that was the force of me cutting the legs which shattered the chip. I wouldn't have thought so, although I don't really recall seeing any cracks in this, so it's well and truly dead now. But we're fairly confident that it was faulty beforehand. I did take another look around all of this just to make sure there was nothing else missed, and there actually was. I found one more trace between the 7400 and this resistor pack up in there. One more broken trace. Again, it was just a trace detached from a hole underneath the socket. So another patch wire is involved on the bottom side of the board. But I think that is now everything picked up from this area. Now, I know we talked about this 245 previously, but I don't actually think that is faulty. Got the scope out, got this set to its trigger mode, and if I go on to one of the pins on the B side where we've seen everything high before, if I reset the board, there's a switch on the side here that will reset it. You can see that has picked up some activity just initially while the board is coming out of reset. Now, it doesn't look right. That, for example, that is definitely wrong. But that sort of makes me think that this 245 is in fact okay. There's nothing wrong with it. But what could be causing the problems then? Well, it has to be something screwing up the data bus, or screwing up that B data bus. I think that is the key to it all. Could be wrong, but I think that's where the problem lies. And short of it being a failed component somewhere, like say the floppy controller, or maybe one of these customs, well, the only thing that I can think of really is going to be the RAM. And certainly, out of the 4 RAM chips that we had off the board and tested, 3 of them are bad. It sort of makes you think that there might be more problems in here. And if enough of this was bad, it certainly would stop the machine from starting. I think it would. Now, I know on a newer machine, if there was no RAM installed, it still will start to an extent. You know, it'll start and throw postcodes at you. It'll beep at you. This board is doing nothing of the sort, although I'm not sure in terms of the 8088 if it would work like that. You know, if the RAM is all faulty, or if some of the RAM is faulty, stopping it from starting up can't get far enough just from reading out of the ROM that it would give you postcodes or error codes. Now, I do have one of these things, but if you plug that in, well, you can see that there's nothing happening on that either. I'm not 100% convinced though that this actually works. It has been lying in my drawer for quite a few years, and in fact I did plug it in backwards once, so I have probably nuked it. The reason to say that is because the reset LED, the bottom left hand corner of the LEDs that are there, that is lit. That shouldn't be lit at the minute, and we know the reset signal is working okay. So don't really trust this thing. But equally, I don't really trust the RAM on here. So I'm wondering if I should just remove all of that. It is going to be destructive though. It is just going to have to be cutting it out. Well, it's a couple of hours later and I now have one set of legless RAM ICs removed from the board. Just cut all of those legs off and then desoldered them all individually. Yeah, that took forever. But it's been replaced with new sockets and tested good RAM ICs. Well, these ones were all tested using this thing. The 4164s, unfortunately I can't test them in this. And short of pulling out an Amiga to test them in, well, let's just say I'm fairly confident that these chips are good. But yeah, I fear this is the last roll of the dice. Because if it's not a RAM problem, well, The only other thing that I can put it down to is a catastrophic failure in one of the major ICs, possibly in this Faraday IC, which is essentially running the show. But yeah, that's enough waffling. Let's throw the power and see what it does. No signal. So yeah, it's not working. Anybody have any ideas? Because honestly, I am completely out of them now. Hold on a second. Did that PC speaker just make a noise? Progress. That is definite progress. It has never done that before. And we've had it powered up for quite a while, you know, when we were testing the various signals about the place. One thing that I haven't actually shown you yet is on the video side of it, there's a set of dip switches here, and these are for selecting the video mode. Now, the way it's set there at the minute with all four of them off, that's the way it came to me, and that is setting it for monochrome video. Now, throughout the course of my testing with this, I have been fiddling with this, trying different video modes, but it hasn't made any difference. And to be honest with you, I just expected that monochrome video, you know, would work. We would get the composite video signal over that, over the monochrome setting. But if I turn this off, and if we turn on switch 2 and switch 4, that sets the video to an 80 column mode. And so let's just see what that does. As I say, I have tried this before off camera. It didn't make a button of difference, but let's just see out of interest. It's working. I cannot believe it. Commodore PC BIOS Rev 4.36. And it's counted 512K of RAM. There's that noise. So that was an error message because it didn't find a hard disk and didn't find drive A bad. It's because they're not connected. And it wants me to press F1 to continue. So yeah, the first thing that jumps out there is, why did it only detect 512K of RAM, not the full 640? Maybe those 4164s do have a problem. Or perhaps more likely, what I need to do here is run the configuration disk, which I don't have unfortunately. But maybe what I need to do is run that to configure the BIOS on this, to configure the amount of RAM that is installed. I am genuinely a little emotional right now because I've been working on this for 3 weeks, and you have no idea how close I was to just calling it. But yeah, a couple of bad logic ICs and some bad RAM. So let's just finish off by going for broke. Keyboard, we'll hook that up. And yes, I have tested the keyboard. There's nothing shorted on this. So it wasn't this keyboard's fault that that resistor there went bang. I think what's happened is somebody has plugged in a non-compatible keyboard. But we'll plug that in and we'll plug in the 2 drives. Now, truth told, I don't really expect this to boot. That's because we can't configure the BIOS on this, but let's just see what happens. Any life in the keyboard? Yep, caps lock key's working. It has picked up a stuck key though. That might have been because I was pushing keys while it was trying to scan the keyboard. Okay, it has given us an error, but the floppy drive did seek there, and I'm fairly sure I heard the heads unlock in the hard drive. F1 to continue. Hard drive's trying, but it's not happy. No? It's booting, is it? It's trying to boot. Oh, it looks as if our hard drive is full of errors. Now, I wonder, is it maybe because I have it up on its side? So let's try it again at that. Yeah, no error out of the keyboard this time because I'm not screwing about with it. No, the drive is definitely struggling. Yeah, same problems again. And yeah, the machine has just locked up. Or no? So it is trying to load stuff in there, but nothing but read errors off that disk. So I think what we'll do is we'll power it down for now. And yeah, this video has been running on more than long enough. So we'll maybe just close things up at that. We now have a working computer, but obviously the case and the keyboard, you know, all of this needs a really good clean, needs a good going over. That hard drive, I wonder is there anything that we could do to possibly save that, or at least try and image it, because as we've seen there, it was trying to boot into something. I didn't quite catch what that program was called that it was loading, but it was dated 1987. And so yeah, I think it would be pretty cool to try and figure out what that was. Trying to get a look at the contents on the drive on this and try and figure out the history of this machine. Well, that took us on quite the journey, didn't it? We now have one working board. Not for a lack of trying on my part, because, well, yep, hands up, I caused significant damage to this section around where the battery was. 28 patch wires in total. Granted, at a glance you could only see 2 of those. The rest of them are all just small trace repairs, but there is still 28 in total, and yeah, I'll be honest with you, it has made me question what I'm even doing here. It has even made me question the future of this channel, if I even should be undertaking these sort of repairs. But I suppose, look, it is all a good learning experience for me, as well as yourselves watching, because as you know, on this channel I don't hide any of the gory bits. What you see is what you get. I made a mess of this one. I was able to recover it and get a working machine out of it. Yeah, it never should have happened, but it is what it is. You know, it obviously had suffered more extensive battery corrosion than I was giving it credit for. And I suppose in hindsight, what I should have done from the outset was just cut off those ICs. Because even trying to desolder them, they just fell apart, legs were falling off them. So they never were going to be reused anyway. So yeah, going forward, I would like to get your feedback on that. And I'm sorry to end this video on like such a down note, but I would genuinely like to get your feedback, and please feel free to be as critical as you want. Is it maybe time that I hang up the tools in terms of this sort of repair? Because yeah, okay, it works, but it's not really in the condition that I had hoped it would be by this point. We are not done with the machine though. You know, we do want to come back to it because obviously everything else still needs a clean. And sorry we didn't get to those ports today, but this video is definitely long enough. They all need to be replaced, or in the very least polished up. They are quite rusted. And we didn't get the chance to take a look at the mouse port, did we? It does need a Commodore bus mouse. I'll need to do a bit of homework to see exactly what that is. On the hard drive, yeah, want to have another go with that to see if we can get it reading any better. Because there's bound to be software on this bespoke to this machine. In fact, speaking of software, one thing that I do need a hand with, if anyone could help, is the setup disk. There's no BIOS per se on this. You know, you can't press delete while it's booting to get into your BIOS screen or anything like that. Rather, you need the setup disk to get in there and configure the BIOS. So if anyone has a copy of that, or anyone knows where I could get a copy of that, please let me know. And that's not just only getting a digital copy of it, that's getting a physical copy, because I only have this disk drive. I do have other machines with 5¼ inch drives, so I suppose I could try and write an image of the setup disk using one of those, but if anyone has access to the actual disks and could lend them to me or make me a copy of them, I would be forever grateful. But yeah, that'll do us for today. Genuinely, please do let me know in terms of that wee bit of feedback I was asking for. Just stick it down into the comments. And yeah, next time we'll try and sort out all those other bits. So, see you then.